They're very close to us, they're almost us, but they're not quite us.
For generations, Neanderthals were dismissed as brutish cave dwellers, a species trapped in the shadows of history and destined to vanish without a trace. Textbooks painted them as primitive and short-lived, their legacy ending in cold caves and scattered bones. But the truth, as modern science now suggests, is far more elusive. Hidden within the fragments of Neanderthals' ancient DNA lies a strange discovery, one that unsettles our most familiar narratives about where they came from and what became of them. These genetic whispers do not tell a straightforward story of rise and fall, but instead point toward true origins that are tangled, surprising, and still very much connected to us today: the mysterious relatives. For more than a century, the image of Neanderthals has haunted our imagination. They were not mythical beasts or distant strangers, but close cousins who walked the same landscapes as our own ancestors. Fossils scattered from Spain to Siberia revealed powerful bodies, wide noses, and skulls with heavy brows that marked them as different, yet recognizably human. Archaeologists uncovered stone tools beside their remains, hearths filled with ash and animal bones split open for marrow. What these fossils tell us is that our species, Homo sapiens, is 100,000 years older than we thought. We are a third older than we realized. These discoveries told us they were skilled hunters, toolmakers, and survivors of the Ice Age world. But one question lingered in the background. Where did they come from? At first, scholars assumed the answer was simple. The earliest Neanderthal fossils appeared in Europe, so the story was written that this was their homeland. Generations of textbooks repeated the claim that Neanderthals were a European branch of humanity shaped by the cold and the glaciers. But as more evidence surfaced, that neat story began to crack. Fossils in the Middle East blurred the boundaries between Neanderthals and early Homo sapiens. The discovery of bones in Central Asia pushed their range far beyond Europe. Step by step, it became clear that the Neanderthals' world was larger, more connected, and far more mysterious than anyone had expected. Some scientists suggested an African origin, pointing to the shared ancestor we had with Neanderthals hundreds of thousands of years ago. Others insisted their story began in Europe, where their distinctive features emerged from earlier populations. Still others proposed a wider homeland stretching across Eurasia, where waves of migration and climate shifts could have carried their ancestors across thousands of miles. With each new fossil and each new excavation, the debate grew sharper, but the mystery remained unsolved. The arrival of ancient DNA analysis in the late 20th and early 21st centuries promised to change everything. Tiny fragments of genetic material preserved in teeth and bones offered the chance to test theories that had long rested, only on skull shapes and stone tools. If DNA could be recovered from Neanderthal fossils, it might reveal not only their relationships to us, but also the hidden paths of their origins. Yet, when the first results appeared, they raised more questions than answers. The Neanderthals stood before us as a riddle. Their bones were familiar, their tools recognizable, their presence across Eurasia undeniable. But the trail of their beginnings remained shrouded. Were they children of Europe, wanderers from Africa, or products of something stranger that spanned both East and West? The only way forward was to dig deeper into their DNA, and that search would open doors no one had expected, splitting from us. Now, genetic DNA studies reveal a staggering truth. Neanderthals and modern humans are not distant cousins, but kin, both tracing back to a common ancestor who walked the earth nearly 500,000 to 600,000 years ago. This ancestor likely roamed parts of Africa and western Eurasia, eventually giving rise to several branches of the human family tree. One of those branches would lead to us, Homo sapiens. Another would take shape in the icy forested lands of Eurasia and become the Neanderthals. For decades, fossils alone guided these reconstructions. One of the most important sites is Cima Delos in northern Spain, a deep cave that preserved the remains of more than 24 individuals dating back around 430,000 years. Their skeletons carry traits that look undeniably Neanderthal. Strong jaws, heavy brows, and facial structures, hinting at the features that would later define the classic Neanderthal face. Yet, when researchers extracted ancient DNA from these bones, they encountered a puzzle. The nuclear DNA clearly aligned them with Neanderthals', but their mitochondrial DNA, inherited only through the maternal line, surprisingly closer to Denisovans, another archaic group found much farther east in Siberia. This contradiction was more than a quirk of data. It suggested that Neanderthal history was already entangled with other populations, even in its earliest stages. Perhaps their ancestors had exchanged genes with Denisovan-related groups. Or perhaps an early wave of humans had introduced new mitochondrial lineages that lingered for thousands of years. Whatever the explanation, the findings shattered the idea of a straightforward split and raised the possibility of a much more complex web of relationships. The timing of that initial split also matters. Somewhere between 500,000 and 600,000 years ago, the shared ancestor population divided. One line would eventually become us, carrying forward innovations that spread from Africa. The other line, the Neanderthals, began adapting to the harsh climates of Europe and Western Asia, but this was not an instant separation. Populations overlapped, shifted, and interbred in ways that make it difficult to draw sharp boundaries. The Sema fossils remind us that what looks like a family tree on paper often resembles a braided river in reality. And the deeper scientists looked, the stranger it got. East meets West. When the first complete Neanderthal genomes were sequenced, they revealed something unexpected. Neanderthals were not one uniform population stretched across the vast expanse of Eurasia. Instead, their DNA is divided into two main branches. In the West, populations thrived in Europe, leaving behind fossils from places like Vindia Cave in Croatia and sites across France and Spain. In the East, another group lived thousands of miles away in the Alai Mountains of Siberia. Though separated by immense distances and harsh environments, both groups were clearly Neanderthal. And yet, their genetic differences told a story of long isolation, punctuated by surprising reunions. The Alai Neanderthals carried distinct signatures in their genomes, markers that showed they had diverged from their Western cousins for tens of thousands of years. Yet traces of shared ancestry revealed that at various times, waves of migration allowed one group to replace or mix with the other. Climate shifts, changing animal herds, and the opening or closing of migration corridors meant that Neanderthal populations were never static. One moment, the East might be dominated by a lineage connected to Europe. The next, it could be replaced by a local group with its own history. This back-and-forth movement means that Neanderthals were not defined by a single homeland or a single path of evolution. Their presence across such a wide range shows that they were highly adaptable, able to survive in the cold steppes of Siberia as well as the milder forests of Western Europe. But their genetic record complicates any attempt to draw a neat line through their story. Instead of a tidy tree with clear branches, the evidence points to something more like a web where groups split apart, drifted for thousands of years, and then came back into contact to exchange genes again. One striking example comes from a Neanderthal genome found in Chagarskaya Cave in Siberia. Despite its location in the Far East, this individual's DNA showed closer affinity to Neanderthals from Western Europe than to the nearby ally Neanderthals, who had lived in the same region earlier. Such findings reveal a pattern of population turnover that must have stretched across enormous landscapes. Neanderthal groups were not isolated pockets, but part of a shifting, overlapping network that reached from the Atlantic coast to the heart of Asia. But how did these scattered groups stay connected across such vast distances? The answer lies in the highways of ice and stone. Highways of ice and stone. The Ice Age was not a frozen monolith, but a restless cycle. Vast glaciers advanced and retreated, carving mountains, damming rivers, and opening new landscapes for animals and humans to cross. During colder stages, ice locked Europe into an unforgiving wilderness, pushing life southward into refuges. When the climate warmed, those frozen barriers melted away, turning valleys and steppes into broad green corridors where herds of mammoth and bison roamed. Neanderthal bands followed these animals, drawn into fresh lands, pulled into encounters with strangers who had walked in from another direction. The Caucasus was one of the most critical of these corridors. This rugged region sat at the heart of the continent, a hinge between east and west, where Neanderthals could not avoid meeting one another. To some, it was a wall of impassable peaks, but to others, it was a gate, opening routes that linked Siberia to Europe. DNA studies reveal that the Caucasus acted again and again as a genetic exchange point, where populations split, merged, or were replaced entirely. A group could hold the region for thousands of years only to vanish when climate pressures drove in another wave. The genetic record captures these movements with surprising clarity. Some Siberian Neanderthals turn out to be more closely related to Europeans than to earlier locals, suggesting entire migrations that erased older lineages. At other times, fossils in Central Europe revealed DNA that traces back east, showing that the flow was not one way, but a constant back and forth. Even mitochondrial DNA tells a story of hidden upheaval. Whole maternal lineages vanish from the record, replaced by newcomers, as if waves of migration repeatedly washed across the land, carrying fresh strands into the Neanderthal web. This back-and-forth history shows us something important. Neanderthals were not a single stable group with one birthplace to point to. Their identity was built by movement, shaped by a geography that never stood still. They were like a braided river, each channel carrying its own history, sometimes running alone, sometimes weaving back into the main flow. Over hundreds of thousands of years, this weaving produced a mosaic of populations that together made up what we call Neanderthals. It is here that the mystery of their true origins comes into focus for the first time. Their beginnings were never about a single homeland, but about networks that spanned the cold highways of Ice Age Eurasia. They were a people born not of one land, but of endless crossings. And just when this braided network seemed tangled enough, another mysterious species stepped in. The Denisovans' encounters with Denisovans, the Neanderthal story, becomes even stranger when another shadowy branch of humanity enters the picture. The Denisovans, for years they were unknown to science, invisible in the fossil record, except for a few fragments of bone and teeth found in Siberia's Denisova cave. Yet from those scraps, DNA revealed an entire population that had once ranged across Asia. Unlike Neanderthals, who left behind a long trail of skeletons and tools, the Denisovans are ghosts whose presence is mostly written in genes. And those genes show that they were not strangers to the Neanderthals deep in the Alai Mountains. Neanderthals and Denisovans lived within reach of each other, sometimes even in the same caves, though perhaps separated by time. Their encounters were not fleeting. Genetic evidence proves that they interbred, leaving behind hybrids that carried signatures from both sides. In fact, Denisovan ended up with significant chunks of Neanderthal DNA woven into their genomes. Some of these borrowed genes proved valuable, especially those tied to immunity and fertility. Through such exchanges, survival strategies were passed back and forth, strengthening both populations in the harsh environments they faced, but the relationship was not unidirectional. Neanderthal DNA also carries hints of Denisovan contribution, though the exact exchanges varied across time and place. In East Asia, the pattern is particularly strong, showing that encounters between the two groups happened more than once. Rather than being isolated, sealed-off people, they were strands of the same wider network braided together through repeated contact. Each meeting blurred the lines of identity, reminding us that these categories, Neanderthal, Denisovan, and modern human, were never as clear-cut as we once imagined. The genetic traces tell of a world where survival demanded connection as much as competition. When groups met, they sometimes clashed, but they also shared not only technology and hunting grounds, but also bloodlines. These crossings enriched their descendants, giving them a genetic resilience that would ripple forward through time. For modern humans living today in parts of Asia and Oceania, Denisovan DNA still lingers in small amounts, shaping how the body adapts to altitude and disease. That legacy exists only because Neanderthals and Denisovans once walked the same ground and saw each other not just as rivals, but as potential kin. What emerges is a picture of prehistory far more tangled than once imagined. Neanderthals were not solitary human wanderers on the edge of Europe. They were part of a complex web of people bound together by migrations, meetings, and mixtures that stretched across continents. Their true origins lie within this braided web of connection. And denizens were one of the most important threads woven into it. But Neanderthals didn't only meet Denisfaun. They met us, and those encounters would change humanity forever. Meetings with us. For hundreds of thousands of years, Neanderthals lived in their braided world of shifting climates, migrations, and encounters with other archaic humans. Yet, the most consequential meetings of all were with a species that was both familiar and utterly new to us. Modern humans, Homo sapiens, emerged in Africa and began their slow spread outward. Fossils and tools show that our ancestors were already pressing into the Levant over 100,000 years ago, where they brushed shoulders with Neanderthals in places like present-day Israel. These early contacts may have left faint genetic traces, but the real impact came much later when larger waves of Homo sapiens swept into Eurasia. Around 47,000 to 50,000 years ago, modern humans entered Europe and Asia in numbers great enough to transform the balance. Neanderthal DNA evidence reveals that during this period, interbreeding became widespread. Every person alive today outside of Africa carries a small fragment of Neanderthal ancestry, usually between 1 and 2%. At first glance, that may seem trivial, but across billions of humans, it represents a massive legacy. It is proof that Neanderthals did not vanish without leaving their mark. Instead, they became part of us. The genetic inheritance was a mixed blessing. Some Neanderthal genes improved our resilience, strengthening immune systems against Eurasian diseases and influencing the skin and hair, adaptations that helped humans survive in colder latitudes. Other inherited traits, however, proved less kind. Certain Neanderthal variants are linked to greater risks of conditions such as diabetes, depression, and even vulnerability to severe respiratory infections. What Neanderthals passed on was not a perfect gift, but a double-edged sword, carrying both advantages and burdens into the modern age. Archaeology hints at more than genetic exchange. The overlap of tools and cultural practices suggests that Neanderthals and modern humans observed one another, learned from one another, and perhaps shared ways of shaping stone and bone. In some regions, the toolkits of both groups blur together, making it difficult to separate one tradition from the other. These encounters were not single dramatic moments, but ongoing interactions that left lasting imprints on bodies and cultures alike. For Neanderthals, though, the story was less fortunate. While their DNA entered our lineage, our expanding presence began to crowd them out. Larger social groups, more flexible technologies, and wider networks gave Homo sapiens advantages that Neanderthals could not easily match. The meetings that connected us also marked the beginning of their final decline. Yet, even with this shared legacy, Neanderthals themselves were falling into decline. Decline of a people. For more than 300,000 years, Neanderthals endured. They thrived in Ice Age Europe, adapted to the cold of Siberia, and weathered the endless rhythm of advancing and retreating glaciers. Their braided history had bound together distant groups from east and west, woven through encounters with Denisovans, and finally with us. Yet even the strongest rope can fray when pulled too tightly. And by the last stretch of their story, the strands that held them together were beginning to unravel. The early Neanderthal genome, one of the most complete genetic records ever recovered, provides a window into this fragile world. The Alta Neanderthal DNA shows unusually long runs of identical sequences, the kind produced when parents are close relatives. In her case, they may have been half-siblings or an uncle and niece. This degree of inbreeding reveals not a rare accident, but a larger reality. Neanderthal groups were small, often isolated, and forced to reproduce within their own limited circles. Over generations, this narrowed genetic pool made them less resilient, more prone to inherited disorders, and less able to respond to sudden changes. The environment offered little mercy. The Ice Age was not a stable backdrop, but a relentless cycle of upheaval. When glaciers advanced, Neanderthals were driven into scattered refuges where food was scarce. When climates warmed, they ventured out again, only to face shifting landscapes and new competition. Each retreat and recodify cost them energy and numbers. The very corridors that once braided populations together now became bottlenecks, straining already fragile communities. And then into this precarious balance came Homo sapiens. Our species arrived in larger, more connected groups. We built broader networks of exchange, shared tools and ideas across vast distances, and adapted technologies to exploit almost every environment. Archaeological evidence shows that while Neanderthals continued to produce skilled stone tools, the scale and speed of innovation among Homo sapiens created an edge. The competition was not always direct violence, but it was decisive. We could survive where they struggled. By about 40,000 years ago, the Neanderthals vanished as a separate people. Their caves were abandoned, their tool traditions faded, and their voices were silenced. It would be easy to see this as an extinction, the simple end of a line. Yet DNA tells another story. Even as Neanderthal groups dwindled, their genes flowed into us, leaving traces in our immunity, our appearance, and even the way our bodies respond to disease. A part of them endures still. Their disappearance was not a clean break, but a transformation. The last twist in the braided history that shaped them. Neanderthals' ancient DNA finally reveals that their disappearance was not a clean break, but a transformation. The last twist in the braided history that shaped them. And it is within that transformation that the greatest revelation emerges. The strange legacy. For a long time we believed the Neanderthals were gone, erased from the story of humanity as if they had simply failed. Yet ancient DNA proved otherwise. Their legacy did not vanish with the last hunter on a windswept steppe. It lives on in us. Every person outside Africa today carries fragments of Neanderthal DNA. A hidden inheritance stitched into our biology. This inheritance shapes us in subtle yet profound ways. Some Neanderthal genes strengthened our immune systems, allowing early humans to survive new diseases as they spread into unfamiliar landscapes. Other fragments influenced our skin and hair, helping our ancestors adapt to the colder, darker environments of Ice Age Eurasia. Even aspects of metabolism, how our bodies process fats and sugars, carry Neanderthal fingerprints. In these ways, they equipped us to endure. But they were not humans with only kind gifts. Natural selection quickly removed many harmful fragments, creating deserts in our genomes where Neanderthal DNA is almost absent. Yet the pieces that remained, the ones that helped more than they hurt, rose in frequency, spreading across millions of people. Their story became entwined with ours, not in fossils or stone tools, but in living bloodlines. And here lies the strange discovery. Revealed by their DNA, Neanderthals has never had one single homeland, one neat origin to point to. Their history is a braided journey woven from east and west, shaped by endless migrations and encounters. They were bound not only to each other across vast landscapes, but also to Denisovans, and finally to us. What once looked like the story of a vanished cousin is in truth the story of how deeply interconnected the human family has always been. Neanderthals disappeared as a separate people around 40,000 years ago. But their disappearance was not the end. It was a transformation. They survive in our genes, in the way our bodies fight disease, in the way our ancestors adapted to the world. To understand their true origin is to understand that there was never a clean divide between them and us. There was only one combined river of humanity flowing in many strands, sometimes separating, merging, always shaping what came next. So perhaps the real mystery is not why Neanderthals has vanished, but how much of them still walks among us. If you found this journey into our shared past fascinating, don't forget to like the video and subscribe for more deep dives. Are Neanderthals truly gone, or are they still part of who we are? Let us know in the comments. See you in the next video.